In this video, I am going to walk through the connection of a PS2 keyboard. In the next video or later videos, I will work on the interrupt handler and the assembly coding that might go with this, but this will at least get me ready for that. In my system, I have last connected, in the most recent video, the 1602 LCD to one of these programmable peripheral interfaces, or PPIs. In this video, I'm going to use PPI number 2, this other one that I've got in my circuit, which is pretty much already connected into everything minus the actual keyboard circuitry to the right. And so that'll be the focus, is let's get this here to the right connected in. And if I just walk through this at a high level, first let me preface this. This design came from Ben Eater's work, or his video series on PS2 keyboard. How does a PS2 keyboard work, and how to actually build a circuit to capture keyboard input, followed by writing assembly code in 6502 assembly to actually do something with that keyboard data. So this is a circuit I've used in my 6502 builds and in my 65816 builds, and I'm just carrying it over here to use it in this 286 build. What I have for components here is a PS2 connector, and so this would be, if I end up doing this out to a PCB, and actually I did order up a PCB just to start experimenting, but that's this connector right here. So I can plug a PS2 keyboard in to the left side of the system board here, and with that plugged in, I'm going to read out a couple of signals from it. There's a clock signal that I'm going to pull from it, and there's also a serial data signal that I'm going to pull from it. Besides that, there's power and ground, or VCC and ground. These color labels you'll see later in the video, where I'm actually connecting the PS2 connector, since I'm not doing a PCB yet, but I'm connecting a version of it to connect into the breadboard. Those are the colors of the wires in my PS2 adapter, so that's what those are corresponding to. So I'm going to have a PS2 keyboard plugged into this. I'm going to pull two signals from it, a clock signal and a data signal. And then down here I've got an inverter. So this is a Schmitt triggered hex inverter basically, so just basically an inverter. And then over here to the right I have a pair of 74595s, and those are 8-bit shift registers. And basically if you want to learn how this circuit works, I would encourage you to go watch Ben's videos. But essentially what's going to happen is when I press a key, that data comes through this line here, which is going to be this serial data coming in. And there's also a clock that's generated from the keyboard. And so this clock will pulse a certain number of times, and then that helps me understand how to interpret the serial data, or when to read the serial data that's coming from the keyboard. And this circuit, essentially what it does is it sets up an interrupt. So I now have this interrupt source that I am going to later connect to my interrupt controller. And so when I press a key, basically this interrupt will be raised once it's waited long enough for the serial bits to come in that represent the scan code of the key being pressed on the keyboard. And that serial data is coming in, and it's going to be shifted into these two shift registers. And then what I can do, once this interrupt is essentially raised or triggered, I can then go out and read the values out of these shift registers to get the actual scan code. And then somewhere in my processor, in my assembly, I'll have to then respond to the interrupt and read that data and do something with that scan code, convert it to an ASCII value, for example, and display it on my LCD. Also, I am going to hook up a bar graph, an LED bar graph, to these data lines. So I've got 6 data lines here, plus the next 2. Those are my 8 data lines right across here that tell me that this is the scan code that came from the keyboard. And so that circuit's pretty simple, not a lot to it. Like I said, I've used this many times, and it's worked consistently and worked well. If you do want to understand how that works better, do go take a look at Ben's videos. He does a really nice job of walking through that. And then you can see that I'm going to pull this all into port B of my PPI number 2 as far as reading those values. So today my goal is to hook up this and get it connected to the PPI, but not actually process anything in the PPI or in the 286 yet. That'll come in a later video. So with that, here is me getting this set of ICs and this connection up and running. Okay, and now here the system is connected up, and what you're going to see now is as I press a key, that LED will flicker on when I have basically an interrupt. And so you're seeing that here, that normally the LED is off. I press a key and the LED flickers on momentarily, showing me that there's an interrupt. And then also on that bar graph to the right, that is the data that is coming from those shift registers. And essentially what you're seeing there is the value of that scan code that came from that key on the keyboard. So as I press different keys, you'll see that those scan codes are coming through and being displayed on the LED bar graph. So that takes me to the next video, where now I am going to connect in the interrupt into an interrupt controller and see if I can figure out how to get interrupts running. And once I get past that, then I can actually try to write some assembly that reads the value from those shift registers through PPI number 2, and then try to display the value on my LCD.